Hello students, welcome to my class. In my last lecture, I was discussing about the geometrical isomerism in coordination compound. So today, I will continue with the same topic and will discuss few more information related to geometrical isomerism. Is it clear to you? So let's start, friend. Geometrical isomerism. As we know, geometrical isomerism is possible when the coordination number is either 4 and the coordination number either 4 or coordination number 6. Is it clear to you? I was discussing if the coordination number is 4, then how many type of possible arrangements are there. Look at, if the arrangement is like this, MA4, not possible, friend. If it is written like this, MA3B, if it is written like this, wait for a moment, MAB3, friend, then again not possible. Now, if MA2B2, then there is a possibility of geometrical isomers. Again, if I write here MA2BC, is it clear to you? Then again the possibility of geometrical isomers. And here if I write MABCD, then there is a possibility of geometrical isomer. In last lecture I have discussed about this and this one and this one. Today I will discuss on the composition, that if MA2B2C structure or MABCD structure, then what will happen? Is there is a possibility of geometrical isomers or no, or not? These all are square planar complex, friend. Square planar complex. Is it clear to you? Square planar complex. They have a square planar geometry. Now, friend, I am moving here. If a coordination compound having formula like this, MA2BC, is it clear to you? Then whether there is a possibility of geometrical isomers or not. If I take an example, if I write here PTNH3 whole twice ClNO2, this is the example. This is MA2BC type. Now, whether it will show geometrical isomerism or not. So, let's check, friend. If I take MA2BC, now first of all find out which type of possibilities, which type of possible arrangements are there. If I write like this, if we apply permutation combination, then we can write the possible arrangement is first of all AABC. This is the first arrangement, AABC. Is it clear to you? Now, the second arrangement will be like this, friend, MAB and AC. Is it clear to you? Now, find out, is there any other arrangement? If I write like this, BAAC or BACA, both are same. So, in this case, only two possible arrangement is there. Now, find out how to arrange themselves. Look at, as we know, if coordination number is 4 and here the geometry is square planar geometry, friend. Now look at what will happen in this case. First possible arrangement is, friend, AABC. Now write here AABC. This is the first arrangement. Now moving here, what about the second arrangement, friend? Tell me. Wait for a moment, friend. That is M, this one is M, this one is M. Now, the second arrangement is, friend, ABAC. AB, then AC. Is it clear to you? If there is a coordination compound having formula MA2BC, then there is two possibilities. First arrangement is AABC. Second arrangement is ABAC. Now, if you try another arrangement, it is not possible. So, if a coordination compound having formula MA2BC, then there is a possibility of formation of two geometrical isomer. Now, tell me which one is cis and which one is trans. AABC, opposite, same ligand, are opposite to each other. So this is a trans isomer and this is a cis isomer. Is it clear to you, friend? Now, friend, I am moving here. Now, if anyone asks you a coordination compound having formula MABCD, that is all ligands are different. Now, what will happen in this case, friend? Whether is a possibility of geometrical isomerism or not. Now, check it out. So, first of all, we have to find out how many types of possible arrangements are there. Is it clear to you? If I write like this, friend, M, the first arrangement is A, B and C, D. Is it clear to you? This is the first type of arrangement, friend. Now, if I write here M, A, C, B, D, is it clear to you? Now, this is completely different from this. This is a second arrangement, friend. Now, if I write here M, A, D, B, C, is it clear to you? Now, this is the third arrangement. Now, tell me, except this, any more arrangements are there, friend? You will tell, no sir, there is no possibility. So, the possible number of geometrical isomerism in this case is 3. If a coordination compound having formula MABCD, that is all 4 ligands are different, then in this case, friend, there is a possibility of to show 3 geometrical isomer. Now, what is the possible arrangement in this case, friend? Can you help me? It's very simple. As we know, these all are square planar complex. Is it clear to you? These all are square planar complex. Wait for a moment, friend. Okay. Now, write here metal, then there is metal, then metal, then metal. Then here M, M, then M, then M. Here is again M, metal, metal, metal and metal. Is it clear to you? Now, look at the arrangement. That is A, B, C, D. First arrangement is, friend, A, B, C, D. This is the first geometrical isomer. Now, the second arrangement is, friend, tell me AC. Right here, A, C, B and D. This is the second arrangement, friend. Now, the third arrangement is, friend, A, D, B, C. That is A, D, then B and then C. This is the third arrangement. So, if a coordination compound having formula MABCD, then there is a possibility to show 3 geometrical isomer. First combination, this question is from a competitive examination. This one is VVI. First arrangement MABCD, second arrangement is, friend, MACBD and the third arrangement is, friend, MADBC. Is it clear to you? I think now you are very much familiar how to find the geometrical isomers of a compound having coordination number 4 and the geometry is square planar, not tetrahedral. Is it clear, friend? Now moving here and going to rub this part. Wait for a moment, friend. So, now you can easily say if there is a A4, A3, A3B and AB3, in this case no GI is possible. This is a final table. In this case 2 geometrical isomer is possible. Is it clear to you? In this case 2 geometrical isomer is possible and in this case, friend, 3 geometrical isomer is possible. Is it clear to you? So, if the coordination number of a compound is 4 and the geometry is square planar, what I am telling, friend, and the geometry is square planar, then there is a possibility to show geometrical isomer. But if the formula is Ma4, Ma3b or Mab3, then there is no possibility to show geometrical isomer. Is it clear to you? And if Ma2b2, A2bc and ABCD, then there is a possibility to show geometrical isomer. Now if the coordination number is 6, now in this case there is a possibility to show geometrical isomers. If the coordination number is 6, then the geometry is, friend, octahedral. That is, the geometry is like this. This is metal, this is metal, 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 ligand, ligand, ligand and ligand. Now here is ligand and here is ligand. This is the structure of octahedral complex. So if the coordination number is 6, then there is a possibility to show geometrical isomer. Then which type of composition will give geometrical isomer? If I write like the formula Ma6, if I write like this Ma5b, is it clear to you? If I write like this Ma4bc, is it clear to you? If I write like this Ma4b2, is it clear to you? If I write like this Ma3b3, if I write like this MABCDEF, is it clear to you, friend? Now if the composition is Ma6, if a coordination compound having formula Ma6, Ma5b and Ma4bc, in this case there is no possibility to show geometrical isomer, because each and every time we will get the identical structure. So we cannot differentiate the two structure. Due to this reason, if the geometry, if the composition, if the coordination compound having composition, having formula like Ma6, Ma5b, Ma4bc, then there is no possibility to show GI. The main here, if the coordination compound having formula Ma4b2 or the Ma3b3, then there is a possibility to show geometrical isomer. Here the coordination compound can show geometrical isomer. If I write here PT NH3 whole thrice Cl3, this is the composition Ma3b3, then there is a possibility to show geometrical isomer. And if I write like this, friend, PT NH3 whole 4 Cl2, then again there is a possibility to show geometrical isomer, because the geometrical isomer having formula Ma4b2, and again in this case, friend, what is the formula? That is Ma3b3. In such situation we can say there is a possibility to show geometrical isomer. Now how it possible, I am going to discuss. I am moving here. Now first of all, if the formula is like this, that is Ma4b2, what I am telling, friend, Ma4b2. Now what are the possible arrangement? As we know, coordination number is 6, therefore the octahedral geometry, it is like this, friend. Now put here M, put here M, then M, then M. Is it clear to you, friend? Now arrangement is like this: A, B and B. Is it clear to you? A and B and B. The second arrangement is, friend, it is like this. This one is a metal, this one. Now here A and A, and then B and B. Is it clear to you? Same ligand opposite to each other. Now look at the question, read the question carefully. I am giving you a few seconds. A blue colored complex Fe4, FeCN hol 6 hol thrice. A blue colored complex, average oxidation number of Fe is A. Okay. Oxidation number of central iron atom is B. Yes sir. And the oxidation number of the counter iron atom, this one is central and this one is counter. Okay, wait for a moment. This one and this one. Okay, this one is central, this one is counter, that is this one is B and this one is C. Okay, we have to find out the value of A, B, C respectively. So let's start how to solve the question. I'm giving you a detailed solution, then we'll discuss the answer. Now let's move here. Solution of this question, look at what I'm telling, listen carefully. The compound here is Fe4, FeCN hol 6 hol thrice. This is the compound. Now it will dissociate like this, 4Fe3 plus, then no need to write plus, you can write like this, 3FeCN hol 6, 4 minus, this is the simple case. Now total iron here is 4. Now 4 into 3, okay, and here is Fe is in +2 oxidation state. Do you need to find it out? Find it out. X plus -1 into 6 is equal to -4. Yes sir. X minus 6 is equal to -4. X is equal to -4 plus 6. X is equal to +2 oxidation state. Clear? So 3 into 2, 3 times iron. Total number of irons 4 plus 3, 7. Put here 7. Now multiply 4, 3, 12 and 3, 2, 6. The average oxidation state is 18 plus 18 by 7. This is the value of A. Okay. Now what is the oxidation state of central iron atom? Sir, the oxidation state of central iron atom is +2. That is, this one is +2. This is the value of B. Yes sir. Now what is the oxidation state of the counter ion? This one is the counter Fe. And here is +3 oxidation state. This is the value of C. Now we can say that is the answer. A is equal to +18 upon 7. Yes sir. B is equal to +2 and C is equal to +3. This is the answer. Now check out which one is the correct option. A is equal to 18 by 7. Okay. B is equal to +2 and C is equal to +3. So for this question C is the correct answer. Now I am going to rub this part and we will discuss the next question. Wait for a moment. Now let's move to the next question. CONS3 hol 4 NO2 Cl shows which type of isomerism? First one is linkage isomerism. Yes, possible. Linkage isomers is possible definitely, because this is ambidentate ligand. If it is ambidentate ligand, then it can be represented like this: NO2, yes, then ONO. One times nitro and second time nitrito, O and N. Linkage isomer, clear. Geometrical isomers, then definitely if the component have formula Ma4B2, then it can show geometrical isomers. Here is also Ma4B2. Yes, it shows geometrical. Optical isomers, no, there is no optical isomer is possible for this linkage. Now next one, check it out. Linkage possible. Ionization isomers, yes, NO2 has charges and this will exchange their ionization isomers is possible. So in this case what will happen? Linkage isomer possible, geometrical isomer possible, and ionization isomer is possible. So which is the formula? Linkage, ionization and geometrical. So C is the correct option. Clear to you? Linkage, ionization and geometrical isomerism. This is the clear explanation. Now for optical isomers, we people know chiral center and plane of symmetry. We have to check it out. So in this case no optical isomerism is possible. Clear? 3 isomer: linkage due to the presence of ambidentate ligand, formula cis and trans is possible, A4B2 geometry, and octahedral complex because the coordination number is 6, and ionization also possible because their NO2 has charge, NS3 has neutral molecule, so ionization is also possible. So 3 main isomerisms possible: linkage, ionization and geometrical. Clear? I am going to rub this part and we'll discuss the next question. Wait for a moment. Now which of the following has 2 geometrical isomer and is also non-ionizable, that is no charge? As we know, if a complex has formula Ma4B2, now look at here, if I write like this, PT NH3 and Cl2, Hall 3 and Cl2. This is this is not non-ionizable. This one is not possible. If I write here PT NS3 Hall 6, then Cl4, no possibility to show geometrical isomers. If I write like this here, PT NS3 Hall 4 Cl2, there is a possibility to show geometrical isomers. In this case, similar, this pattern is similar, but here is this one is not non-ionizable. Ionizable, minus and plus charge are possible. If I write like this, if I put here PT Cl4 into NH3 Hall twice, look at this is formula Ma4B2. If this is a formula of Ma4B2 and there is no such charges, then in this case what we observe, there is a possibility of geometrical isomer, one condition satisfied, and non-ionizable, not ion presence here. So in this case what is the correct option? C is the correct option. Clear to you what I am telling? We have to check 2 things, not only geometrical isomer, we have to check out geometrical isomers as well as non-ionizable complex. Non-ionizable, that is no presence of charge. So this option satisfy the whole criteria for these questions. Clear? Now wait for a moment. Now let's move to the next question. Which of the following cobalt complex is paramagnetic high spin complex? As if I talk about this complex, CO and CO, C2O4 and CO, CN Hall 6. Clear to you? What will happen in this case? Check it out. For in all the cases, that is, they form diamagnetic complex, not paramagnetic complex. What I am telling, they form diamagnetic complex. If I talk about COCN6, look at CO3 plus, that is the oxidation state, and the outermost electronic configuration is 3d7. Clear to you? Now for 3d7 what will happen? Check it out. 1 2 3 4 5 1 2 3 4 5, then 6 and then 7. Due to the presence of Cn minus, a strong field ligand, what will happen? Pairing will take place. If pairing will take place, then tell me what will happen. That is CO3 plus 3 electron, so electronic configuration is 3d6, not 3d7. Only put here that is 3d6. Now pairing will be done. What will happen in this case? Check it out. It can be represented like this: 1 2 3 4 5, 1 2 3 4 5 6. Now pairing, this will come here, this will come here. So in this case the hybridization is D2sp3, that is diamagnetic substance, no unpaired electron and low spin complexes. Clear to inner orbital complex. Similar here, one more thing. Clear to you? If I talk about CO, here cobalt is in 3+ oxidation state. For cobalt, in this case, what will happen? That H2O will work as a high strong field ligand. Due to this reason, again pairing will take place. If there is pairing take place, then we can say again it will form inner orbital complex, that is high spin complex and diamagnetic in nature. So which of the following cobalt complex is paramagnetic? High spin complex? None. So the answer of this question is none of this. Clear, friend? If you have any doubt, you can easily approach to me. I used to tell such words. Now wait for a moment. Now let's move to the one more thing. I have to modify this question here, put here 3, because cobalt in this option I didn't check in this option, that is CO. It will write X minus 2 into 3 oxalate ion, that is equal to minus 3. X minus 6 is equal to minus 3. X is equal to minus 3 plus 6. X is equal to plus 3. This is the correct order. This one, minus 3 plus 3, done. Now you can say none of this. I have modified this because these are this form stable complex. So for this question, D is the correct option. Clear? Now let's move to the next question. The next question in this case is question number 5. Which of the following ligand is ambidentate? As we know, what is ambidentate ligand? Ambidentate ligand are those ligand which have tell me two donor atom, and at one time there is one donor atom attached to the central metal atom. In this case, this is ambidentate ligand. Clear to you? Here is also ambidentate ligand, and this one is also. But what is chelating ligand? That is best chelation. That is the case. It form the best ring structure around the central metal atom and will form a most stable compound. Look at the condition, chelation, ring type structure. So for this, D is the correct option. Clear, friend? What I'm telling? For this, D is the correct option. Now let's move to the next question, next section of the question. Question number 6. Which of the following pair of molecules have identical shape? Now identical shape, if I talk about NiCl4, xenon F4, a simple calculation by prediction we can say they do not have the same hybridization. But if I talk about Zn-H2O, so second option, check it out. Zn is in +2 oxidation state and the coordination number here is 4. If the coordination number is 4, either sp3 or dsp2 hybridization is possible. Yes, in Zn. And if I talk about H2O, H2O is, friend, that is the weak field ligand. Yes, if it is a weak field ligand, then the hybridization will be sp3 hybridization. Clear to you? What I'm telling? The hybridization will be sp3 in case of Zn-H2O. If I talk about SiCl4, check it out. What is the formula to find the hybrid? X is equal to 1/2 the valence electron here for silicon, that is 4, and monovalent atom is 4, that is 4, 4, 8, 8/2 is equal to 4. So hybridization is sp3. What we find here, that is in case of Zn-H2O whole 4 and SiCl4, the hybridization is sp3 in sp3. If I talk about the first option, Ni is in +2 oxidation state. Am I right? Ni is in +2 oxidation state. So it can